Good morning, good afternoon, and good evening, depending upon where you live around the world. We're back again, and it's been a couple of days since I made the last video. I have been pondering and mulling over just how we want to approach the connection between the hub and the strut, whether it be the parallel configuration or this angled relative to the strut configuration. The screw is really a secondary, significant, but certainly a secondary component for that attachment. Mainly the screw actually is to stop it from flopping backwards and forwards or sideways. But it's the interface, and regardless of whether it's square to the strut or angled to the strut, both the rod and the screw needs a washer that's got a wedge or an angle to it so the head can bed onto it properly. So in that endeavour, if I started, whoops, sorry about that panning around, I created a square, well, I had a square piece of solid steel, drilled a hole in the end of it, and then cut them to the prescribed angle I want for each strut. That's quite a good, it's nice and solid. The edges actually align themselves with the inner curve of the hub, so that's actually got quite a good it's a nice interface. This, however, is a bit of round stock that we drilled a hole through that was a wee bit loose on the shaft of the bolt or the screw, and it self-aligns because as the head of the screw pushes against this face, it will find its own place for locating on the inner curve of the hub. So that's got a lot of merit. And then I thought, even though this shows a wee bit of a small bore, but we think of this as a water pipe, a galvanized water pipe, where we can cut it on an angle and it'd be easy to cut. It looks quite attractive as far as the aesthetics go in the hub, and quite a good idea, I thought. It doesn't nest well into the curve of the hub though, whereas this one does. It's the water pipe along, this axis, and once we've cut it on an angle, of course it will nest into the curve of the hub very nicely, thank you, like we show here. Doesn't look pretty, but it acts well. If we hide that, that looks nice and neat, not bulky, and it has the unfortunate issue of it not nestling into the curve of the hub. That can be addressed, I think, by a little bit of tickling up with a grinder file and maybe a curved section, which will be in another video. If I create it, I'll actually make up a mock-up of it and take some photos. But I think we can address the bedding in or mating in on that. And in the process of doing this, I've realised that these things are actually called taper washers, and you can actually buy them. Now, whether you can buy them and I can buy them where I live, or you live, well, that's a question. I can't ever recall seeing these sorts of taper washers in my banging around all the years I've banged around, and that's the point. We may see things on the internet or in photos, proceed to think that they must be obtainable where we live, and find out a rude awakening that they're not. So be careful. And again, I'm still not too certain about how we go, whether we have a bottom rod, whether it be square to the strut or angled, or whether we actually make this rod more central, which is probably the better place for it, I feel, and could be a point of where the energies or forces are calculated from, out from the centre line, just as we see in struts, rather trusses, when we're making the designs. Many of the designs are considered to be best done through the centre line of the member, whether it be the bottom chord or the top rafter in the truss. So if that's true, makes sense to have the rod. Not that it needs to be in the centre, but the point of force would possibly be calculated from there and is more neutral. Anyway, that's a thought. Am I over-egging the problem or the situation? Well, you could say so. However, I've seen some more photos, and I'm just going to draw a couple in where it shows a collapsed dome. Now I'll just draw one in, and this is it here, and it's blown apart. I've got a feeling there was something else to this story that I'm not aware of, but I can't see how it was in this. Well, there was a big ring foundation poured, and it can't have been attached, and the wind's come along, bit of bad weather, and it's rolled it off of where it was sitting and just smashed itself. Because this is not a collapse through downward pressure, this is total devastation, probably through the wind, well, obviously through the wind, and it has just absolutely munted it. I'll draw in another photo, so I'll hide this. And this is one of the hubs in that same dome. Now, just take note as we zoom in that these timbers, being 4x2 or 100 by 50, if that's correct, which I think it is, because I saw other photos where they're constructing and it looked about right, this hub is probably 75, 80 mils in diameter, and these screws are what? 40, 50 mils long, and it really looks like there's only a single screw per strut. I don't believe there was any star type strap on top of it. I saw the photos, but I didn't save them. But really, who in the right mind would attach an end grain with a tiny, like I use a screw almost that length when I'm hanging a door. So, no, there must be something else I'm missing, but maybe I'm not, because the thing, blew apart. And we know that domes are strong, but when they're constructed like this, yeah, not so much. I'll hide that one, and I'll bring this in. Now this is a very large water pipe. It's more likely to be like 200 millimeters across, quite thick in the wall, of course, because it's a heavy duty pipe, plastic of some description. But look at the length of the bolts that they've used again. Now, if this is the strut that they're using, this is possibly 75 by 25. Now, why they'd use something that light with a hub this big, I'm assuming that the only reason using a hub this big is because they got it cheap. And you can even just see that this is not a long screw. And for them to be using that in end grain, and it was a good sizable dome, I'll scratch my head. Like I said, am I over-egging the problem? Yes, but because domes do fail, structures do fail, and what we're seeing, the ones that I've seen, often they failed through the attachments at this point here, an ingrained. The same one with the quadradome that we looked at, a quadrasphere, where someone had ripped off that company's design, and they made a hash of it. It was anemic what they'd done. They looked like they had coupling nuts or nut couplers inserted in, and they just pulled out. Not good. And the company, rightly so, were a bit annoyed because it gives their domes, which would look similar, of course, a bad name. So I'm not over-egging it. I may be fixated a little bit too much at this stage because I haven't actually constructed it, but the concerns are real. and we want to get it right. And that's why when builders, engineers look at something like this, for me, without the ability to calculate it, I have to err on the side of caution. And no, I don't accept the argument that, Dave, there's thousands of domes been built and they've never had a problem. And I'm going, well, great. There's lots of people go through red lights too until the time it actually kills someone. So I'm overly pedantic about this bit because I don't have that input from someone that can allay my concerns. And besides which, at this stage, it's just chewing the fat over the ideas. And maybe when I get my butt off the chair sort of thing and can post them, these videos, I can get feedback from someone that knows more than I do. Okay, well, I'm going to leave it at that. We're going to look at making a star plate connection in the workshop. I had been resisting doing it because I'd actually fixated on the fact that they needed to be laser cut. Well, no, they don't. They can be workshop cut and tidied up with a grind or a linishing belt. So it might be something that I'll do in the next short while, because I can see the benefits of star plates and how they can be placed in one of or a combination of places, bottom, middle or top. And having a concern, you would just double them up, one on top, one on the bottom, eliminating any stress as to the timber. And so long as you've got sufficient fixing through the plates, it eliminates a lot of these issues. And maybe a little bit of work to get it, but is this a little bit work too far? And again, this was designed with the idea, let's do it in a home workshop. Starting to get that itchy feeling that maybe I've gone down a path that will become redundant and the star plates will replace it. We'll see. Maybe it's even a combination, like I showed in another video. I don't know whether I've kept the video where there was a large dome, 22 meters in diameter, and they actually used a combination of hub, like this, steel hub, and star plates, or the wings, and they were welded to it. Because if you've got your strut pushing up against a solid surface, it then redirects the energies around to the other struts, and it's just a nice combination where the straps hold everything together, but the pressures can be loaded through a steel hub rather than loaded through the actual fixings, the screws or bolts. The bigger the dome, the bigger the fixing, so that would need to be bolted. So yes, interesting. Rightio, it's going too long now. I'd better wander off and leave you alone. Okay, see you in the next video. Bye.